Hello everyone and welcome to Pwny Racing. This is the live CTF racing competition where 4 participants will try to be the first to solve a pwnable challenge while I and my co-commentator provide some analysis and commentary on what they're doing. Usually I have Bob with me, but today we have a different commentator and challenge author, one of my other teammates, Lars. Hello, Lars.
Hello, Kalle.
Great. And we are today here not as usual in our home and so on. We are sending live from CCC in Leipzig. And we have our contestants here on site. And I would have liked to show you like a picture of the setup here because it looks pretty cool. But we couldn't get at the work. But if you have been following the episodes and you like pony racing, we are hosting a little bit of a meetup afterwards, after the episode. So we are hanging out around the Exil assembly in the hall 2, I think. You can check the nav. So that's XIL assembly. So come and meet us here after the episode if you want to discuss the pony racing concept. Anyway, we're gonna get into the episode. So I'm gonna introduce the participants for today. If you give me a second. Today we have PewZ from the Norwegian CTF team Bootplug. We have NSR and niklasb from eSleep Pwn Repeat, and phLaul, DEFCON speaker. And they are all ready to go, I think. I'm just going to check with the participants. Okay, you ready? Okay, so we will start the race in 3, 2, 1, go. So, good luck to all the participants. And I will try to sort out the audio issue. I apparently only have audio from one channel, so I will try to sort that out. But anyway, Lars, maybe you could just tell us a little bit about what's special about today's challenge.
Yeah, I think the idea for today's challenge started out with you buying about 10 Arduino boards for the Risk Your Hack Me challenge that you want to go all wild on. So you had the idea that we should have an challenge for the Arduino or the AVR to try out pwning on a new architecture. So the challenge today is each participant has been given a board of their own that they have to analyze. And the target today, I'm not really sure if you managed to get that set up, but you were speaking earlier about that you wanted to have a sort of an alarm.
Yeah, so we didn't get that set up properly. So it's just there's a flag in the memory of the board, and the participants need to get it out. And that's the setup. And we wanted to do some fun thing and hook it up to some lights here at the venue, but unfortunately we didn't manage to do that.
And we can already see that some of the participants have started to look at it. They have been, I think it is PewZ who is doing some dynamic analysis here.
Yep.
He's trying to run the serial terminal. He has connected and he is he's now looking at the main function and to see how it's constructed. And the way this, they don't hear us now, do they?
No, they don't hear us.
No. So you can see there from the main function that this challenge is actually built like a small real-time operating system with 5 threads that do some communication. So in the main function that we was looking at a bit while ago, you can see that there were 5 functions that do the task initialization, and then there are 5 tasks running in a loop. But we will see. I'm really interested to see what tools they will use. We can see that we're going for IDA here.
Yeah, with PewZ, and if we check with NSR, so yeah, he's doing some just interacting with the challenge a little bit. You can see some serial communication there on the right side, and also actually using AVR GDB. So is he running like a simulator or something for the firmware maybe? The participants were told in advance that it was going to be AVR pwnable. We didn't want to be too cruel to them because it's not your everyday architecture that you typically work with unless you work in a very specific field or something.
Yeah.
But we can moving on.
If we look at phLaul, we can see that he's in the main function right now.
Yep. Also using IDA, and
yes.
Here
you have this 5 set up. You can see.
Yeah, so it calls a few initialization functions, and then it goes into this like processing loop, right? You think that's the general idea. When I've been trying to use IDA for AVR disassembly previously, I've had the issue with the this like 8-bit, 16-bit addressing problems where the addresses would have incorrect labels basically, and you needed to like resolve everything by hand. But I don't know, maybe they've fixed that, or maybe you can just do the calculations on your own.
Yeah. The thing with the AVR is that it has a separate address space for the program memory and for the actual RAM. So you need to be a bit careful in your mind that you're dealing with the different kinds of addresses.
Yes.
I think niklasb is having some problems with getting his serial communication going.
Oh yes.
He's still working on that. But yeah, now we got it.
Yes, so we got the serial communication working. You can see there the reset message that's sent by the device and the prompt. So
yeah, he actually found the help command.
Yeah, that's very useful. So this is it's a small interactive shell or whatever, where you have these instructions: help, set, debug, and reset. So yeah, what do they actually do? These functions?
Yeah, the help command just shows this little prompt, and the set x, where x should be from 0 to 9, sets the PVM level of a LED. So I will see if they find that out if they actually look at the board while they are. Yeah, now we got it. I'm not sure if he's looking at the LED at the same time.
Oh right, because you will actually get visual feedback on the board.
Yes, and now he has got the debug message there as well. And the debug message will be crucial. We will look into that later when they actually find out what the system is doing and what because there is the bug in there.
Yeah.
But
we can move over to.
It comes from.
Sorry, yes, you were saying the bug.
No, I was just thinking about. I got this idea to this bug while looking at some serial communication drivers for several different systems, and I've been thinking of if I should do something with this someday. And now it's a challenge.
Yeah,
so
nice.
We'll see if they find it.
So if we look at PewZ's screen here, I saw that he was actually doing some debugging and like single stepping through some code. So it looks like he did manage to get a working AVR simulator going, which is really nice. That will simplify things a bit, I guess. Being able to run it on your own computer and see what's actually happening. Though the challenge should be, I mean, we tried to make it simple, but yeah, it's not easy to make a like a simple challenge, that's still somewhat interesting.
Yeah, I think there will be some steps to this challenge. First, like finding out what it is doing, and then finding the bug, then finding out how to trigger the bug, and then we'll see if you get the solve the challenge. No one of the participants are using Ghidra for this. I had not
Yeah, it's
expected that, because Ghidra has quite it's a challenge before we released it. But I didn't try Ida because I didn't have an AVR version of it.
no, I mean the IDA, it disassembles AVR, but it doesn't have a decompiler for AVR, while Ghidra can actually decompile AVR.
Oh, we have Ghidra here. I wasn't saying anything.
Oh yeah, look here. NSR is using.
NSR is doing Ghidra.
Yeah, and if you can see the decompiled output there, it looks very clean, I would say.
Yeah, except for you can see some the concat statements for it doesn't handle 16-bit integers very well.
Okay, right.
So it's doing some concatenation instead when it's loading the 16-bit address, 16-bit addresses into the 8.
Yeah, that's cool. Let's move over again to Niklas. So he is looks like he's like renaming some of the data, some addresses in, here of the various like global data. Yeah, it's like he's writing input there. So he found where the input buffer is stored, which is important.
Yes. So I think it was confused there because there was one offset missing, and this because the set command only checks the first and the fourth, skips the fourth byte, and then takes the 5th byte value to get the set point.
Yep.
So now he's looking into the command handling function for how this is actually going to be treated. So it sets the value, it takes the input value, subtracts the ASCII value for 0 and multiplies with. So this lets you set up, I think, 250, but not up until 255. And that there is another monitor task that, he understood that this is ASCII now. So he has now seen that the input it compares to ASCII.
All right. Yes. So I haven't really seen. I mean, usually when we do these episodes, you will very quickly see some of the players like creating like some boilerplate code for their exploit for communicating with the target to do some initial, just to automate everything. But I think here they haven't really done that since maybe it's they're not familiar to the same extent with this architecture, so maybe you don't even know what you're going for. So they started out more like with some more analysis before they actually start doing some exploit code. That could be the case. We can look at PewZ here. So seems to have a good debugging environment, like stepping through the code and comparing this to the disassembly from IDA. Just, I guess, like getting oriented, finding his way in the firmware and like what's executed when and so on. We can see also now Niklas has actually opened Ghidra as well.
All right.
Which is interesting because I don't think he uses that a lot.
No, but he looked at it first in IDA and now he's changed.
Yeah, exactly.
So
You can see him switching back and forth between them. And actually, this is what I find myself doing regularly when I'm dealing with these like non-mainstream architectures, because I think all of the different tools like IDA and Ghidra and Binary Ninja, they have, they're all small pros and cons, so I can easily find myself having like all three of them open at the same time and just switching back and forth with them, between them. Yeah, it's not as straightforward when we're dealing with this architecture. That's a bit different. Yeah, so maybe for those who are not familiar with the AVR architecture, Lars, could you just maybe give some of the like highlights, like what really sets it apart from like ARM or x86 that people are used to?
Well, it's designed to be run on microcontrollers, so not general purpose computing. And it was designed quite recently, around 99, I think, if I remember correctly. And it's made to be compiled. You're not going to write it by hand, although you can. But it has, I think, 32 registers, separate flash memory and separate RAM, different address spaces. Although the registers are mapped to RAM, so you can actually send the offset of a register that it will be written to, which is strange but interesting. Yeah, the most different part of it is that is an Harvard architecture, which means that it has different program space and RAM space. And I've tried to use that in this challenge a bit as well, because some of the strings are stored in the flash memory, and some other variables are stored in RAM. So you can see that it's loading from flash when it says LPM, load from program memory. So this is you have different load and stores instructions for different different memory areas.
No. So it also uses these. It has some of these like double registers where you can access the same registers, or like you have 16-bit registers that are combinations of two 8-bit registers, and that can also look a bit strange when you're disassembling, because the names are really not related at all. It's like, what is it, like number 27 and 28 are mapped to the X register or something like that, if I remember the numbers correctly, and then it's like 29 and 30 and 30 and 30, 31 and 32 or something, which means that you can in some places it can be like move things into register like 27 and 28 and then suddenly use the register X, but then that's actually the same value. So if you have a smart disassembler, it would kind of indicate that somehow, but otherwise you have to just know that this is how the registers work. We can again check in with phLaul. So you can see that he was looking a bit at the different strings in memory, or like the constants in the firmware. But yeah, looks like he's using the Arduino IDE to compile some example programs, I guess, and then disassembling those, maybe, to just...
I saw some of the participants pissing on other AVR programs before the challenge started.
Yeah. We can see here, looking at Niklas' screen, and trying to... So what part of the code would this be? Is it the main file? Oh, like, so he thinks that he found the flag function. So yeah, so we probably should say this as well, that in this case you're not really expected to get like arbitrary code execution. Instead there is a what do you call it, like a critical failure shutdown function that will print the flag for the participants. And yeah, how do you trigger this function then?
Yeah, this PVM level that you can set, when it goes on a critical level, so that is in this case 255, then the monitor function will issue the alarm and give an emergency shutdown code.
Okay, but you can't set it to 255 manually, or?
No, you can set it to something times 28. And I think that is, I by design didn't put any hard limits on what you could put there, but if you take something times 1 times 28, then that will always be even, and you cannot get to 255.
All right. Yeah, so they will have to find another way of setting it to 255 specifically.
Yes.
So we can check in with NSR. You can see there the compilation of the main function, as we said, that looked really clean. That's very similar to what the actual source code looks like. But I mean, it's also very simple. It calls a few functions for some initialization, and then it's just an infinite loop with handling some tasks. So, yeah.
Yeah, I don't think it handles the watchdog setup that nicely. But I'm not sure if there are any flirt signatures for AVR widespread.
I would almost be surprised if there was. So we can see here, LarsH is just looking at some at the Arduino support forums and at questions. I wonder what he's searching for. Uno enumerated as USB. Oh, maybe it's having some issues with connecting to the board. I don't know. I'm not sure if I've seen all the players interact with the board yet. So yeah, we'll see. Hopefully he will sort that out. All right, so he is on Windows, so maybe he needs drivers for this CH. What's it called? CH340. It's like USB to serial emulation chip that you will typically find on a lot of these devices. Yeah, but that should hopefully not be too much of an issue for him. So we can move over to PewZ again, and yeah, he's back in IDA, looking at the code. It's a bit unclear exactly what he's doing at the moment, since they don't really have like an exploit code. But you can see that he is running a debugger. You can see that he's done some calculations there in the corner. I guess he's figuring out which values you can set. You can see the 28 there, right? Yes, you can see the 28. So he's probably thinking about what values you can actually set the PVM to. Yeah, so what is the vulnerability that they are looking for anyway?
So the vulnerability is in the serial output function, which is a bit odd because it's usually in the input function. But usually when these embedded systems are transmitting a new line character, translated into first a carriage return, then a new line. And in this case, all output characters are stored in a buffer. But if you write a new line to the last, it's a ring buffer, so every increment gets modulus. But if it first stores a carriage return, increment I omitted the modulus there. Write a new line to the last position in the buffer, then you can do a 1 byte overwrite right after the buffer.
I see. And that would you would write outside the output ring buffer then.
Yes, and you will overwrite another offset where you're writing bytes from the from your input, and you can overwrite the global variables with that.
I see. So the what would be like? Can we see if any of the participants? What would be the symptoms of overwriting that? Because you can't really. I mean, you don't control what you overwrite with, right? Because it will always be this carriage return that you overwrite with outside the ring buffer, right?
Yes, but that is an offset for the input, which is checked for equality later. So you can use that to overwrite the global variables, and one of these are the setpoint values for the PVM level.
All right.
But you cannot,
So you
but
would
you cannot output a new line.
Sorry, what? You can't. Lars?
Yes, I think you enable all-time Teams speaker, because I hear you very intermittently.
Yeah, I will. No, I think there was some network issues, but I think it's fine now. I'm broadcasting. Okay, so yes, as we were saying, you can you overwrite the offset right outside the ring buffer, and this would enable you to when you then input more stuff, that input will no longer be stored in the input buffer, but it will start writing elsewhere in memory.
Yes, it will be overwrite other global variables.
Great. So, yeah, and you said something about outputting a new line.
Yes. So you it is only the output bytes are first stored in this ring buffer. They are enqueued, and then there is another task who is consuming them. But it is the only functions that actually enqueue data to this buffer is the command handler itself. And when it has output a command, then it will reset this pointer. So it wouldn't be enough to just use the command the command handler to overwrite with a new line, but you have to use the debug functionality, because there is also a debug function that you can add on that shows, oh, I'm increasing the set point value or decreasing the set point value, and you have reached the set point value. So you must use this output from that function to overwrite with.
Okay. So,
but we will see how they go along and reverse and finding the vulnerability.
Yep. That's really nice. We can check in with NSR. I saw a lot of output here. Oh yeah, that was probably just examining the memory in the debugger. It looked like the output of the X command in GDB, right? So yeah, so he was inspecting this emergency code.
Yeah, he's also saying like not data there as well. So he now found out that the flash memory and the RAM memory are different.
All right. So then yeah, because I actually did not tell them that this was where the flag is, but hopefully it will. They will figure that out. Otherwise, we will probably release that as a hint in shortly. So
yeah, there is one emergency function that displays the emergency code.
Yeah. Yeah, and it's also a bit strange because I mean, you would be curious because it says there's the hard-coded string emergency code : space, but then I mean there is no emergency code hard-coded there. So I mean naturally you would look where is the string used and then see the code that follows, which is a loop that will read from the EEPROM and print that out. So that should catch your attention.
Yeah, you could hope.
Yeah, and we can see here that Niklas is also looking at this emergency code string, and you could see that he was multiplying the address by 2 to get the correct address in memory. This is what I was talking about with IDA, like mislabeling the addresses in AVR because of this like 16-bit hybrid thing.
Yes.
So yeah, it's let's see if we can see any other progress from the participants. It's yeah, I can't. It's a bit difficult to see exactly what's going on. You can see NSR here is still decompiling the code. Is that the like input handling function, right? That he's looking at? It looked like it. So we'll see what's. If he comes to any insights from that. And PewZ is looking at the debug function and or just generally maybe verifying his assumptions. It looks like he's trying the different commands and maybe like following in the code on the right side what different pieces of code are doing. Just making sure that the firmware is behaving as expected. So yeah, it looks like he possibly identified like a string printing function. Oh yeah. Speaking of, we can see here that Niklas is also naming a function to print ? as well. So looks like they figure out the function that does the printing.
Well, it doesn't really do the printing. It's more like enqueue to the send buffer.
Oh right, yeah, that's actually a crucial distinction. So.
Because it's non-blocking all the functions in there, because this is supposed to simulate an RTOS.
Yeah. That's really nice. It's yeah, you can see Niklas has the AVR assembly reference manual as well, and I think that's a very good idea. I mean, it's a pretty good manual actually. It explains the architecture and the instructions quite well, so helps a lot when working through code like this. You can see here that PewZ has also identified this what he also labeled as print, and he identified the argument, how it passes the argument to the function, and it's using two registers, like the 24 and 25, to take the address to the string it's supposed to, well, not print as you said, but to queue for printing.
Yeah.
And yeah, I would like to see some just some kind of dynamic analysis, a little bit of interaction with the board. But it looks like overall the reversing is taking more time than usual in these challenges, which is of course natural considering the architecture. And yeah, we will just have to accept that this probably will not be as fast-paced in the beginning. But however, I think when they finally start getting to the vulnerability, things should start moving fairly quickly.
Yeah, I agree. But it seems pretty even so far. No one is really far ahead from the others. This is no Jinmo episode.
Yeah, exactly. So let's see what's going on with Niklas again. And so he's using this Simduino simulator to try to debug the firmware that we're running. And
yeah,
let's see if that works for him. I think I've used this previously. Yeah, he's verifying that the addresses are correct. Like you can see that he's inspecting the addresses in memory. So you can see he there's a variable there that he has named mode flag, and that would be. Is that how the critical thing works? Will it set just a flag for that, or like the emergency shutdown?
I can really tell from this IDA output, but yeah, it will essentially just halt the device and print out the flag.
Yeah. No, I mean, how does it enter? So you have the monitor task, which will check if the PMV is 255, and if it is, will it itself immediately call that function, or will it like set?
Yes, it will itself call the UART send function.
Okay, so it's not like a separate like state that it toggles like we are in emergency mode or something. It will just jump to the flag printer function and run that.
It's basically a glorified panic function.
Okay.
So it will halt the device with an infinite loop, which actually does a watchdog reset, so it will be kept alive. So when any of our participants reach this state, then the microcontroller will get stuck there.
Yeah.
And this was our first thought that it should light a lamp or something, but
I had to do some cuts in the ambition of the setup because we had some other technical issues that we had to prioritize. So yeah, no fancy blinking lights or so.
Yeah, and niklasb was just naming this function checker, the monitor task.
Okay, yeah, that's the correct insight, I guess.
It is actually, but it is actually not the checker. This is the adjustment task that is slowly adjusting the PVM value up to the target value.
Yep. Okay. I see. We can see. I think I saw like yeah. So here you have LarsH communicating with the device, the serial monitor. So, and that's the debug function, right? With all these the pluses. That's it's printing out, right?
Yeah, the individual increments
Okay, so
of the PVM value.
So the set command, with the set command, you set the target level, and then there's a task that will like continuously modify the PVM value until it reaches the target value.
Yes, so if you set it to 0, then it will slowly go down to 0, and if you set it to 5, it will slowly ramp up to 5.
I see. And the crucial part is that if you have the debug enabled, it will also print pluses and minuses while doing this.
And target reached with a new line.
Oh, right. So you will have to basically set it to some value and then set it to another value that's the right amount of it's the right difference between the current value and that value, and enable the debug before that, so that it will print a specific number of pluses or minuses followed by targets reached and a new line.
Yeah, that is one way to do it.
Okay.
I am actually hoping to see more innovative solutions, unintended solution lurking in there that you don't know of.
I guess you could go for a bit of a fuzzy approach. I mean, there aren't that many commands to send, so but I guess you need to be a bit lucky to actually discover that you managed to do anything, right?
I would say that you need to be very lucky if you're fuzzing this.
Yeah. Because like if you overwrite this offset, well, I mean, if you do overwrite the offset and then just start inputting a lot of additional input, wouldn't it probably just crash eventually?
Well, it would probably crash and reset itself.
Yeah.
But
so you should be able to discover some kind of crash.
No, actually, when I think of it, the stack is too far away from the this input buffer, and the index in the input buffer is only 8.
Oh, right.
So you can't reach too far away from the input buffer.
Okay. So you can only overwrite some of these global variables, and
yes,
and they are not important to the control flow in that sense. So
no, they are. It's only this the target value of the PVM.
Okay. I see. So you can actually not get a crash. Well, let's look here again at LarsH while he's
I would be happy to be proven wrong that you can actually crash this.
I see. So you can see here that
it would be fun to see.
So it will output 28 pluses per level. Is that?
Yes. And this is because 9 times the 8 is 250, if I don't remember wrong. No, it's 252.
Yeah. I see. So you can see here he's trying like set 2, set 3, set 4, and then he went for a set 6, and he sees that the output is twice the size of the output when he inputs set 3 or 4. So maybe he is about to realize that the number of pluses is like the delta times 28. I am not sure if he did realize that, but that's one of the conclusions you could draw from seeing that, which would be the correct conclusion as well. Let's jump over to NSR again, who is doing some debugging, trying to let's see what he's doing in the output. He okay, now he switched over to Ydra. So yeah, it looks like you could see there he was like he was looking at the input buffer, and then right after the input buffer he saw the emergency thing. But yeah, I think that's one of the big catches with this is that contrary to the usual setup where you have some kind of like overflow in your input buffer, as we talked about, the overflow is on the output side, which is unusual. So, yeah, we'll see what they think about that. We can move over to PewZ, who is also doing some debugging, just also trying to set different levels using the debug command. Is there any way to so that when you type the debug command, will it just turn on the debugging? Like, can you turn it off again, or?
Yes, it will toggle the
All
debug
right.
value.
All right. So, but does this mean that as soon as you have, if you overwrite this, if you manage to do the overflow in the output, would you be able to just send a whole bunch of 255 bytes in a sequence, or do you have to be more precise?
Yes, when you can do that.
Okay.
It will probably work.
Yeah. So,
but if you want to be more precise, you can also be that.
I see. But you will always overflow. I mean, you will always write 1 byte at a time. So you can't like just jump to the right place. You just write the sequence until you hit the right place, right? Or
no, and also you need to be very precise that you're actually at the end of the output buffer when you have a new line.
Yeah. I mean that's the part where you have to be pretty precise. But then when you hit that, what you do after that should be just to send a sequence of FF bytes.
Yes, but then you can't do that from a manual terminal. You need to write some script
right.
Open another terminal, or just go to the to the teletype device.
It's interesting. And and still we have not seen any scripting at all from any of the participants. There was
I think niklasb is coming some places now.
Yeah. So he's named the print emergency code function, and he's looking at this value. So he's naming this check emergency code. Yeah, this is correct. And this memory location.
Yeah, that is the PVM value.
All right. So that's.
That is increased there.
Yes. And here you have the plus and minus outputs when adjusting this value.
Yes.
So he's definitely this is
some magic.
Some magic 2. Okay. That's in contrast to some magic 1. And yeah. No, definitely looks he's getting a grasp of kind of like the setup of the code. So we can jump back to PewZ again, who is again playing around with some input and output. You can see that he made some notes in the bottom right there, and it's still I don't know. It would be cool to see if anybody would manage to trigger this override. Let's see. We've been going on for about an hour now, so still I would say a decent progress. Definitely not as bad as it could have been. This is, I mean, it's unfamiliar and tricky stuff. So we were a little bit worried when we were preparing this that it would be, a bit too complicated. But I think it looks like all of our players has a decent grasp of what's going on. So
yeah, I reduced the complexity a bit because you wanted it easy as well. So
yeah, it's
first I had all these glorious thoughts about having interrupt service routines to handle all this and timers and stuff. So it's all a nice main loop.
Yeah, I mean, I think that's a cool challenge. We might revisit those ideas in some other context in the future. But yeah, I think it was good that we went for something simple here. We can check again with the NSR, who's doing some debugging, trying to trying a bunch, playing around with the inputs and some breakpoints and comparing it to the code. So yeah, it's really not I think straightforward to figure out, because I mean this way the input and especially the output works is not I mean, it's not super complicated, but it's not the first thing you would expect when looking at a device. You would expect something that would just send the output on the serial port. And we can check again here with LarsH, who is trying to set the trying to set the value to 200. Hey, what would happen if you did? No, wait. It converts the input as to an integer. Or how does it?
Yeah.
So you could not write
in a very ugly way. It just ASCII 0 from the value. But this multiply by 28 is crucial because 28 has no multiplicative inverse modulo 256. So you can't reach 255 from a normal value. You need the overflow.
What? Oh, right. Yeah, I was thinking... no, that's correct. You need a... Yeah, so if it would have had a multiplicative inverse, you would have been able to take that value plus ASCII 0 and send the set and that byte value.
Yes.
And... yeah, okay. But that's not going to work because you have chosen this value carefully to not have an inverse. Yeah, that's nice.
Who are we looking at now, by the way?
Yeah, so I was looking at PhLaul here a bit. I was, first I was just contemplating the beautiful maths of group theory and stuff, but now I'm back and looking at PhLaul's screen, and you can see he is just doing some calculations. All right, I think that he is actually, he's actually thinking about this idea. You can see that he divided 255 by 28, but that, I mean, okay, he gets a 9, but that doesn't add up. I mean, it's a truncated division.
Yeah, he will get almost critical, so it's a small taunting message there.
All right. Oh, that's how you get the almost critical.
Yes.
But you are really not any closer to the solution by getting almost critical.
No.
So it's just one of your traps.
Yeah, you can see it was set almost critical.
Yeah. Well, that's. I mean, it's a good insight. That at least that means that he knows exactly how the input correlates with this value that you need to adjust.
Yes. So now they have their target. What are we supposed to do to get the flag?
Yeah.
But now the way there is not by using the set command. It's different.
Yeah. We can look here at PewZ screen. And he is looking up one of the control registers of AVR related to the serial communication. So I guess he is debugging or disassembling the either input or output functions, because the way this communication would work is that, for example, when outputting data, you would write the byte to a register, and then you would continuously check a flag in another register until the data has been sent, and that flag will be reset, and then you can write another byte and do this in a loop to send data on the serial port. And input works similar, right? But you read and reset the flag, or is it reset when you read from the register?
I think it depends on the processor, but I think the AVR resets it on read. If I remember correctly, it is.
So you
that
just
way.
check for like a read ready flag on the control register, and you read that byte, and then you loop.
Yes.
Yeah. So I mean, understanding how that works, you could identify the exact place where the input and the output is performed, and this is actually kind of important then, because you could then realize that the output is actually not performed in this like print function. They are actually decoupled.
I'm not sure if anyone has realized that yet.
No, but yeah, that's probably one of the key insight that's missing here for some of the players. I'm wondering if we should be dropping
Hints.
a hint.
Well, what could we give as a hint then?
Yeah, first we're gonna answer a question here in the chat. So we have a question from Klasma, who asked, "What do you mean that the buff is outside?" What I said was that the buffer overflow is in the output. So I mean, typically when you're dealing with some kind of buffer overflow, at least of the simpler kinds of challenge, you have some kind of input buffer where like you send your data and it's placed in this input buffer, and you overflow that input buffer and you corrupt some adjacent memory. That's your typical simple buffer overflow challenge. In this case, it's in the output buffer. So I mean, this couldn't really happen in a regular operating system. I mean, of course, in theory, but in practice, it really couldn't. So the print function here in the code will not actually send the data over the serial. The print function will copy the data over to an output buffer, and then there is a separate task. You can think of it almost like a separate process, except or like a separate thread, except that this is not multi-threaded, but it's a separate task. And this separate task.
This is actually a multi-threaded program. It has 5 threads.
Oh,
but it's a very low-level threads.
Okay, I mean it's not like hardware.
But it's
threads.
a single core processor.
Exactly, that's what I mean.
No.
Yeah, it's on a single core, but it's five separate threads. So this output task during normal conditions, some other function will write data to the output buffer, and then this output task will take this buffer and send that data in the output buffer to over the serial port. But in this case, you can then, by making the print function being called in the right way, you can write outside the output buffer and corrupt what's adjacent to the output buffer instead of your typical corrupt what's adjacent to the input buffer. So that's what I meant before when I was explaining the overflow.
Maybe we should hint that there is a buffer overflow somewhere.
Yeah, I was considering being even more explicit, but maybe we should start with that actually, and then we can do another one in like 20 minutes.
Yeah.
Okay, cool. I'll give this hint to the players. So give me one moment. Okay, the players. The hint. There is a buffer overflow. Okay, so the players have been given the hint that there is a buffer overflow. So, yeah, you can see here that Niklas has named the PVM value should become FF. So, yeah, it's an entirely correct description of that variable from a hacker's perspective. Let's see. We can check in again.
Oh, I think PewZ actually got something just a moment ago. I saw the critical emergency code on, but it was on his simulator.
Oh, shit.
But I'm not sure if he was just jumping there or if he actually got there. Because it was in the simulator, so I must have just called that function to see what happened.
Maybe he just called the function just to verify that, yeah, like it does what he expects it to. Yeah, because I mean he has still not scripted any communication, so he can't have been sending the FF byte that would be required, right?
No, I think, yeah, he was using it in his simulator then.
Okay, right. Makes sense. So, yeah, and I think I saw something in Niklas debugger as well, like reading from Flash. So, oh, you can see here in Niklas as well that he verified this mathematical problem as well. You can see that he looked at all the bytes between 0 and 255 and checked if any of them multiplied by 28 modulo 256 would result in 255, and the list returned empty. So yeah. So we also had that idea. It's a good idea, but unfortunately it will not work. So, yeah. Oh, now here we have some actual code. So PewZ is actually PewZ is scripting. You can see that he is. He's communicating with the same AVR thing. And just setting up the initial communication, I guess. Yeah, so trying to connect to the device, having some issues with that. I guess he's already connected to it in some other window or something. So yeah, it's he's trying to get that figured out. But finally, we see some scripting here, and yeah, you will need that eventually, so it's good to see them getting started with that, or at least one person. So yeah, it's gonna be really interesting to see if he gets that going, basically. So, here, if we look at LarsH, he has also just started a little bit of scripting as well. Just open the connection and read some output from it. Yeah, he managed to read as well. So he also has like the very, very basic skeleton of the exploit code. And now he managed to read the reset that was sent when you reset the device. Yeah, so some kind of progress from both of those players. So yeah, so we have a question here in the chat, and the question is what the goal of the challenge is. Yes, so usually when we do these episodes, we settle for nothing less than full remote code execution. In this case, to keep the challenge simple, and so what you need to do is you need to extract the flag that's stored on the EEPROM on the board, and you can do that by calling a specific function or getting a specific function executed. So this system has this basically, I mean, it's a variable that you can modify to a certain extent, but if that variable manages to be set to 255, which you can't really do through normal means, the device will go into like a fail-safe mode, so it will call this critical shutdown function, and it will print the flag. So it's basically get the device to go into the critical state. Yeah. So you can see here that LarsH is trying to write some data here, trying to...
Yeah, he's trying to do this overflow and then with FF.
Yeah.
So he's on the right track, but that will not work because there is an input size limit.
All right.
But it's the right thought.
So is that the right amount of... so what's the size? Let's think about this then. So the output buffer is like 32 bytes large, maybe?
Yes.
And the message that is printed is reached, or what?
Yeah, level reached.
Target reached.
Target reached, I think.
Target reached. So that's...
But it's a ring buffer, so you just need to be in the right position.
Yeah, right. So, but that's like 14 characters plus the new line. So, so you need to be at position 17, and then trigger the target reached print.
Well, I think the easiest part is just to see that you didn't get a new line in your reply.
All right, because the function that actually sends the data
that enqueues the new lines. Yeah, you enqueue a new line, but when you send it, you only send the carriage return.
Exactly, because the sender function will actually stay within the output buffer.
Yes.
Right. So that would be a clear indicator that there's a difference. I mean, if you're really careful, like really observant, you could, I guess, discover that by chance. Like if you were sending basically random inputs.
I think if you're just pressing enter like 40 times, you will see that some of the new lines are skipped.
Right. So if you just send random data, basically every 32 outputs or something along those lines would be missing the carriage return.
Yes. No, not the carriage return, but the new line.
Sorry, yes. All right, because yes, that makes sense. It would make
Because the new line will be written outside the buffer.
yes, exactly. Sorry about that. Yeah, that's also something. But it's also, I mean, it's really easy to like disregard. You know, sometimes when you read new lines and carriage returns, you just like they just get squished into one symbol in your head while reading them. At least that's how it is for me in many cases. I could easily miss a detail like that. But you can see here that LarsH is setting up some kind of loop, trying to, let's see. Yeah, so he starts out by sending the debug command.
Good start.
Yeah, so here we're actually seeing something take form. That's it's really interesting, and we can jump over to NSR, who is again doing some debugging on the sorry, I was distracted. Doing some debugging, and now back in Ghidra, trying to, you know, still. So he's disassembling his. Yeah, he's looking around. You can see that he is like looking at the instructions around the program counter, just figuring out what code is about to be executed and like comparing it to what he's seeing in Ghidra to you know, make sure that it corresponds and that everything makes sense. I'm really curious about where LarsH is going with this. Looks like he's having some issues with the Python hanging. That's unfortunate. Hope he gets that sorted. But you can see he's kind of like setting up some structure here in his code. As we said, he would start out by sending the debug command and reading the response. So he's just trying to get all of that set up. We can see here over at PewZ screen. Looks like you can see all the function names there in his IDA view. You can see that he has named almost all of the functions, including one function is named winner. So yeah, that's probably the emergency shutdown function. And he has a few functions that you can see that he has named like maybe at the end, which is a good, in my opinion, like a good reversing strategy, is to not get too stuck in one place. Like if you're looking at a function and you kind of think that you maybe know what it's doing, but you're not fully sure. I mean, just name it to something, but indicate that you're not completely sure about it, and then move on and see if other things you encounter kind of like strengthens or weakens that hypothesis of what the code is actually doing. I found that very...
I think, yeah. Yes, I agree on that. I think PewZ is now having a bit, you see this issue where you have 16-bit registers on the bottom of this function.
All right.
This unknown 100131 and 30. It's 1337, but it's assigned bytes instead of one 16-bit value.
Oh, right. That's another. Yes, that's another real pitfall in this architecture. These 16-bit moves, where you. I mean, the instruction will just say one register, but it's actually the register and the register next to it that will be affected.
Yeah, you need to be sure if there's a W in there or not.
Yeah, But the tricky thing there is like, so it might say, let me see if I can find an example. Like so if you have some instruction with the W and it says like R24, and then later you move something out from R25, you have to keep in mind that
it has been changed.
It has been modified by that instruction, even though R25 is not mentioned in the like textual representation of that instruction at all. Very, very tricky and unintuitive thing when you're starting out with this. At least when you are used to instructions and architectures where all the involved operands are listed in the disassembly. Of course, I mean even x86 has many of those instructions. Typically, for example, is like the division instructions will modify registers that are not part of the operands to the instruction.
Yeah, if you do like IDIV ECX, you will get affect both EX and EDX.
So I mean, it's definitely not a foreign concept with modifying other registers. Also, I mean, almost all instructions modify the flags in the processor, which can be seen as, I mean, they are kind of like 1-bit registers. So, yeah, it's not really a strange concept. So we can see here that LarsH has continued with his exploit script a little bit. So first he is sending nothing, and then he's sending debug, and then set 0. So maybe just trying out that everything is working fine with this setup. And yeah, I'm thinking we're coming up on, so maybe at like 1:30. Yeah, in a few minutes we could actually give them the hint that the overflow is in the output buffer. That would be interesting to see if anyone has already realized that, or if that is new information.
Maybe we should be more subtle, or
we could be. We have a few minutes to come up with
one way would be just try to press enter a few times and see what happens if something unexpected happens.
Press enter 40 times and observe.
Might be mean though.
Yeah, yeah. I mean, you don't want it to be like too much of a Riddler thing, and yeah.
No.
So yeah, I mean.
Yeah, maybe it's better with the output buffer.
So yeah, it should be noted that even though these players are I mean struggling a little bit with this, these are like top class pwners, and
no, we shouldn't go to guessing. We should be.
Yeah. So it's.
I agree.
It's some really skilled players we have here today, and it's really cool of them to participate in this. I think it's really fun, and
even though it's AVR.
Yeah, even though it's AVR, I will not out anyone specific, but when I said that it was going to be AVR, the person replied with, "What? Can I still get out?" So yeah, there was a bit of a frustration maybe, but yeah, we still wanted to do this thing where we have some hardware that they have to hack since we are here on site at CCC, and yeah, as I said, directly after the episode, feel free to come to the Exil assembly. Just talk about pony racing. Maybe you have been watching the episodes throughout the year, have some feedback or anything, just come hang out and talk Pwnables and talk about the episode and the challenge. So if you're here at CCC, please join us after the episode. Unfortunately, Lars is not here on site. It's too bad.
No, not this year. Maybe next year. We'll hope for a ticket.
Yeah, we'll sort that. But let's check in with one of the players. I actually want to check with phLaul again, because I was seeing something that kind of looked like something that could be an exploit. But he's back disassembling, so let's check in with Niklas again. What is he doing at the moment?
Oh, he is in the right place.
What?
Yeah, he's looking at the NQ character. So yeah, this will be interesting. If he can see that there is this modular missing.
Yeah. So he says append to. What did it say? Append to IO buff. Oh right,
Yeah,
so he
and
renamed it. Yes.
You can see there at the fourth line there is a AND with one F, which is modulo 32.
Yeah.
And that is missing in the top line. Let's see if we can observe that.
Yeah. So he is looking. So he's definitely in the right place.
Yeah, that is so spot on.
And he's starting to name all of these things. So I mean, he just has to clean this up a little bit. He's comparing this, so he's jumping back and forth between IDA and Ghidra. Yeah, this is the same function, right? Wait.
Yeah.
Yes. And yeah, append to IO buff. So what he needs to realize is this carriage return and new line handling here.
Yes.
So you can see there right after the append to IO buff, you can see it compares against A, which is a new line, and if so, it does this thing inside where it will load the D, which is the carriage return, and then move. Yeah, exactly. So this is where the overflow is. So it looks like he is looking at that address. 104 should be the address, and then of the output buffer. And then you can see that he has found the calculation of the offset here. So this.
Yeah, we'll see when he realizes that this is a ring buffer. Then it will probably be more clear.
Yeah.
You can see the despair falling back in his chair, just staring at it.
Yeah. Now it's deep thinking.
Deep thinking, but he's on the right track.
He's definitely on the right track. Let's check.
Yeah, now we just mark this no 0xf. So yeah, this.
Yeah, let's check in with PewZ, who. Yeah, I saw him using the serial tube module there in Python as well. So maybe he's starting with some scripting as well. Though I haven't seen anything yet. It's doing some debugging in the simulator. Not entirely sure exactly what he's looking at the moment. So maybe we'll just move on.
So Niklas found the off by 1 now.
Okay. Right. Oh, like you see, he has written a comment here. Can go OOB here will get corrected later.
Yeah, because you can only write 1 byte but if he now can find out what is that he is overwriting, then he will have solved this.
Yeah.
So it's really nice to see. I think he's in the lead now with that find. Yeah, he has the bug.
Yeah. This I would really like to, hear his inner monologue right now. What is he thinking about? But
yeah, if he just can see what it is he's overwriting there, then it will be all clear.
Yeah. If char is A, it will append D first, then A. Yes, that is absolutely correct. So, yeah. I mean, what I would do in this situation, if I wasn't completely sure, is I would actually try to just script this up and see if anything happens. But yeah, it's gonna be interesting to see if he managed to, really. I mean, he's so close to getting it the right way. But now he's looking at the input buffer.
No, he's looking at what he is overwriting, because the input offset is what you overwrite.
Oh, right, yes. Oh, no, right. So you just see that, you saw that he just added, wait, did he run off by one error in his calculation?
I don't know.
You could see that he took the address of the input offset, and then he added 0A to it.
Yeah, that is where you will land later.
Yeah.
But the most important part is that you land outside of the command buffer.
Yeah.
And that you realize that the command buffer checker only checks for equality with 8 and not above 8.
Right. So then you're outside the ring, and you will just continue writing sequentially through the memory. Yeah, I want to.
So now he's looking at the. This is the PVM. Are we looking at Niklas now?
Yeah, I switched back to Niklas,
Yeah.
and you saw something.
Yeah, yeah. He was looking at the PVM subroutine, and because you overwrite several values, but you must realize that you can overwrite a lot of them.
Mm-hmm. Yeah. Yeah, that's interesting. I want to check back with phLaul again. I saw that he was writing some exploits, and I want to see how far he come with that. But so let's see, what code is he looking at right now?
He's at the same function here.
Oh, here is the IO buffer append.
Yeah,
function.
the NQ, but he didn't look much into it.
No.
It's too bad.
Yeah. It's
I haven't seen any of the participants look at the call tree graph of this system. That is something that I usually do. And try to figure out what are the leaf functions who are furthest down, and try to find out what they do.
Yeah, and that kind of ties into something I usually tell people when they ask about advice on reverse engineering, is that I usually, and I think a lot of people do this, combine kind of like two main strategies when reverse engineering. Where you switch back and forth between the two, and one of them being that you start you do like a top-down thing where you look at the large functions, and you can see like the the overarching control flow structure of the program. You see like the main loops and how it branches out and stuff like that. But then you also you do like a bottom-up approach where you start with the leaf functions because they typically have a very specific and well-defined purposes, like input or output or some kind of encodings or encryptions and stuff like that. So it's easy to, or sometimes easy to kind of like identify them and then work your way upwards and see where are those functions used and so on. And then you can like switch back and forth between these two main strategies and kind of, meet in the middle in your analysis. So Niklas has written here, off by 1 here, but only A is possible. Yes, that is correct.
Yeah.
But
that is enough.
Yes, yes. So the only thing that's wrong with this sentence is the sad smiley at the end. That's the incorrect conclusion. The correct conclusion is happy smiley.
Yes.
So we'll see.
Now it's compare. Now it's comparing to 7. So it's branch not equal.
Oh, like that's his setting. This check is useless if input offset
is already larger than 7. Yeah, he has it. Now, he has found the overflow.
Okay, this is...
Or there are actually 2 overflows, because it's 1 off by 1 overflow, then you get an overflow into the command buffer. Now he's looking at assembler instructions for AVR.
Yes. He's looking at the compare with immediate.
And then branch not equal.
Yeah. So he's just verifying what he wrote.
Yeah, that's always good to do if you're on an unfamiliar architecture.
Yes, because you might think that, I know what a compare instruction does, but it's maybe not the same on the architecture you're on.
Yeah, now it's changed it from overwritten, maybe it's overwrite from here. Now we can see all of these values can be overwritten. But this should become 0xf is before that. Yep. But that value can be controlled from with the adjust. So he is on the right track. Exactly as I expected.
Okay, so wait, so you don't actually overwrite the target value. You overwrite the
this value that Niklas has named should become 0xf.
Yes.
It is the current PVM value, yes. But it's ramped up, and this you can set this target value differently.
Okay, so you overwrite the target value, and then the adjuster task will sort things for you and adjust it to the...
Yes.
Okay.
So you need to understand how the different parts of the system interact.
Yes. This is a very clever and deliberate layout of the memory, right?
Yeah, I had so it might be a bit artificial, but this is also racing.
Yeah. No, I saw in the source code these are not like just global variable. It's just one big struct to make sure that they are in the right order and the line.
Yeah, that is one way to fix when you do this kind of pwnables, to make sure that things are in the right place.
Yeah.
But surprisingly often it could be like that in the real world as well.
Yeah. So but I mean, it seems like Niklas is on the right track. But let's check in with phLaul. You can see here he's doing some trying something here. He is sending. You can see there his exploit. He was like writing set 1 and then sending a bunch of A's, and then something else. It's like it's kind of in the right direction, but it doesn't feel like he has this key insight that we saw that Niklas seems to have discovered. Yeah, I want to check in with NSR. It is still messing around in the debugger. Not exactly sure what he is doing at the moment.
I'm a bit surprised to see the debugger approach, because I hadn't anticipated that at all.
No, it's. I mean, of course, it's good to have a debugger, but I haven't really seen if they have kind of found anything insightful or gained anything yet from it. But I don't know. Of course, we can't read minds here, unfortunately. So yeah, we can check in with PewZ again. Yeah, it's done a lot of good disassembly and naming of function here, but yeah, a bit unsure what he is looking at right now at the moment. So yeah, and to all of you watching, like if you have as some of you already done, like if you have any questions or want any clarification of any part of this, then just feel free to write in the chat. There are about 75 of you watching. That's pretty cool. Yeah, so let's move on again and see. So PewZ is writing something here like output buffer at 109-ish. So he is also trying to now he writes, where are you, buffer overflow? Yes.
Yeah.
So the question here now, should we give them all of them a hint? I mean, Niklas still has a head start, so it's fine. I think we'll because there's still some things that they will have to figure out on top of that. Yeah, I will just give them that.
So maybe not look at only input, but also at output.
Yeah, like have you considered the output?
Yeah, that may be a good hint.
Yeah. So yeah, I will just give them one.
And we also have someone in the comment section of the YouTube channel asking for a brief summary.
I will do that. So none of them looked particularly happy about that. Don't know if that helped them. So Freddie Mercury asks if we can give a brief summary, and we also have a question if we can solve it using fault injection. So we could start with the fault injection. Yes, you could.
I guess you could, but it would be a bit hard to get the timing right.
Yes.
Because this is not synchronized on a serial input in some way, but you need to be lucky if you're going it that way.
Yeah, and also, so wait, is it like it's running this check in a loop essentially, and
yes.
So yeah, I mean, if you manage to glitch that specific comparison, that would of course trigger as well. So like a single well-timed glitch would of course then trigger the flag output. But as Lars said, it's not at all trivial to find the timing here. The other consideration is that the participants do not have fault injection equipment, so that's going to be an issue. But yeah, we can have a short summary of what's going on. So
the challenge is running on Arduino Nanos.
Yeah. So
It's not a normal phonable challenge.
Exactly. So these Arduinos, they are using an Atmel ATmega 328P processor, which is a AVR architecture processor.
So what this challenge is actually doing, it's you can set the PVM level, the brightness level of an LED, and over a serial interface. And there is also a monitor task that makes sure that you don't set it that the value does not get too big. And if it does, then it will trigger an sort of an alarm or emergency mode, and this emergency mode will print the flag.
Exactly, and you can't actually set through normal operations. You can't set the value to this trigger value. It will not let you do that. You can set it to you set it to a target value. And then that's multiplied by 28, and then another task will then slowly or fairly quickly adjust the actual level until it reaches this target level. But the important thing here is that 255, which is the critical level that you need it to reach, does not have a multiplicative inverse.
Modulo 256.
Modulo 256. Because this is an 8-bit value. So no matter which value you set it to, if that is multiplied by 28, the result can never be 255.
Or more easily said, 28 is an even number, so you can't multiply another number with this even number to get 255, which is an odd number.
Since the modulo is even.
Yes.
And that means that they will have to get the this value to become this critical value through some other means, and this is by exploiting a buffer overflow, not in the input but in the output buffer. So whenever you want to print something, or whenever the program wants to print or send something on the serial, it will not directly send the data on the serial. It will queue the output in the output buffer, and then a separate task will actually take care of transmitting that over the serial. And this buffer can be overflowed.
So I think PewZ at the moment is trying to also script duplicative inverse here.
Yes. So trying to... I think he made a mistake in his code because...
Yeah, in this comparison, yeah.
Because he's getting basically every answer when he should be getting no answers. So this is it's the third time we see one of the players actually verifying this fact that you can't multiply something with 28 and get 255. Yeah, we'll see. It would be unfortunate if he incorrectly comes to the conclusion that you can actually do this. That would send him down a rabbit hole. So let's see if what Niklas is doing. He is because I saw some reading from. Wait, is it? What would be the name of where the flag is stored? You can see that GDB reading from SRAM, and I've seen like reading from Flash, and I wonder what the simulator will output when it actually tries to read from to read the flag. So now you can see that he calculated 1F minus 9. What would that be significant for?
Yeah, this is how far ahead from the end this target reach need to be.
All right.
I think, but I don't know. We will see.
Yep. So.
Oh, it might be that he's trying to print the normal buffer, but he will see that that will not work.
Yeah.
So he still hasn't got into that you must use the debug function to overwrite that. We also have a question in the chat. Does every participant have an Arduino to interact with? And yes, they have.
Yes, so every participant has an Arduino Nano with the firmware loaded on it, and they have a copy of the firmware on their computer. So the copy of the firmware they have is identical, but the flag is stored in the persistent memory of the Arduino, so they don't have that themselves. Yeah, so we can check with NSR again. You can see a lot of outputs in the form of these pluses, and yeah, I wonder. Yeah, it looks like he is counting size of that output. He missed to copying one of the pluses, so. But yeah, maybe he accounted for that. Otherwise, it would be like a very unfortunate mistake. So there's a question if its flag is encrypted on the RAM. If not, you could dump the RAM and get the flag. So it's not in the RAM, but yes, you could. So we didn't like set the fuses and stuff on these boards, so you could, in theory, just dump the whole EEPROM and get the flag, but that is not allowed. Yeah. So Freddie Mercury said like it's in the EEPROM. Yes, but of course you could dump that with the right tools, but you're not allowed to do that. Just imagine that it's like the proper fuses are set and it's a super secure platform and all of that. We also had a question here for beginners. Could you give any good resource to start? And this depends on like if you mean with Pwnables in general. I would highly recommend the Pico CTF. I mean, that's my go-to advice for starting out with any like CTF in the beginning. But they have some really good beginner Pwnable challenges. Ramp up the difficulty in a nice way, introducing one concept at a time. So definitely check out Pico CTF. Then of course, for kind of like reading materials and stuff, there is a ton of stuff on the internet. I don't know if I have anything in particular to recommend. I would say just start out with some Pico CTF challenges, and then when you get into specific problems, ask people, Google what you're stuck on. I think Pico CTF even has like a help forum where people provide hints and stuff. So definitely check that out. I have a like a recorded lecture here on my YouTube channels called The Basics of Binary Exploitation, where I go through the basics of binary exploitation. So I think that could be a good introduction, but you really need to combine that with some hands-on practice, and for that I don't think anything beats PewZ in like accessibility and good structure. Someone said it's time to start playing Eye of the Tiger from Rocky. Might be. So let's check in with phLaul, who is playing around with the simulator, I think. Not sure exactly what he's doing at the moment. So yeah, it's really difficult to say now how the players are doing. I mean, we know that Niklas has some key insights, but can he convert this into a win? That's the question. Yeah, it's I still would like to see more of the exploit script that phLaul was working on. I didn't see a lot of it, but he could be onto something. And now he's looking at the help print function, I think. And here is the critical check. And so that's the he's looking at the current PVM value there, that it loads into R24 and compares it to FF to check if the level is critical, and if so, it would call that function the 19A, which will be the print flag part. That's the goal. So yeah, it's Lars, are you still with me?
Yes, I am.
Great. Do you have any insight on what?
Yeah, I was looking at what the different players did, and Niklas has added a new comment to his debug. This we need to avoid. I think he is trying to find out how he can make use of this new line print feature. So we need to let some other print put the A. Yeah, he's definitely on the right track. He has now understood that the command handler function cannot be used. That he must use the debug function instead.
Yeah, that is really getting close. So that's let's see. Let's hope he manages to put all of that together.
That should be fairly easy though, if he could see some other place where it is printing.
Yeah, totally.
But he's definitely on the right track.
Yeah.
I think he's way ahead of the other ones.
As a side commentary, there is this big, like, huge Eye of Sauron here or something on top of a wall, and it kind of like sweeps over the area, and sometimes it just, it has a huge what do you call it, light on it, searchlight or something, and sometimes it just lights me straight in the face. Not very pleasant. Anyway,
But how do you like CCC besides the Sauron light?
yes, I mean the Sauron light it's really cool actually. I don't think it is Sauron, but I'm gonna say it's Sauron. Yeah, I mean for those who haven't been to CCC, I mean this is kind of what I imagined that DEF CON would be, and it's probably maybe, I don't know, I'm fairly new to this. It's maybe what DEF CON used to be more, but it's like, yeah, it's like a huge 17,000 people embodiment of, you know, hacker culture gathered in one place. I think it's yeah, it's really amazing.
I haven't been to DEF CON myself, but my impression is that CCC is much more decentralized with the angels and so.
Yeah, I think the organization is I think it's more decentralized like that. But I mean, I don't know. I don't have a big insights. I mean, I know that DEF CON has like a lot of volunteers who put in a lot of work as well. So I mean, it's not like I'm, you know, throwing shade on them. It's a cool event as well. But I just think that CCC is, yeah, it's just just an awesome experience overall. So yeah, you should really try to get here. We can see that LarsH is checking GitHub for the Simduino. Okay, it's the Simduino manual. Just checking the instructions for the flashing and stuff, I guess. So looks like Niklas is gonna try some communication now with the. Is this gonna be with the real board, or is it still with the emulator? I'm not sure.
It's a dev PTS, so more probably a simulator.
Okay, right. Yes, that makes sense. Yeah, and he has a debugger there connected. Trying to find the right device to connect to. I remember this was an issue when using Simduino, that it would I guess it would like properly release the device or something, so you would have to like increment that device number all the time. So now Niklas is writing a lot of pluses as inputs, but that's not.
He has enabled the debug function. Yes, I think maybe he has realized that it's critical.
Yeah. Yeah. So we'll see. We'll see if he gets that. We can check in with NSR, who is also checking around with the debugger again, currently looking at the reset functionality more specifically. And yeah, it's not sure exactly what he is looking at the moment.
We have a question in the chat to do a recap again.
Yeah, so Jordan is asking in the chat, I'm late to the party, but super excited to see a hardware challenge for Pwny Race. Can you do a short recap for folks who joined the stream late? Yeah, sure, we'll do another recap. So for those who don't know, Jordan actually did like the special episode together with some of his friends here on the Pwny Racing. So if you check out the Pwny Racing Seesaw special episode, they did, as part of the Seesaw finals, they did like a head-to-head pwning tournament, a knockout tournament between the teams. So it was a long stream with teams going head-to-head in a knockout tournament, like Pwny Racing style. That was very, very entertaining commentary by Jordan and crew. So definitely check that out. But anyway, as for the summary, So we have all the players with an Arduino board, so AVR architecture, running a firmware that they have also been given a copy of, with the difference that on the board there's a flag in the EEP ROM. But the firmware is the firmware flashed on the board and the one given to them are identical. This firmware controls the PWM value or the PWM of a LED, so you can change the intensity of an LED on the board. If this value would ever reach 255, the fail-safe mechanism of the board would kick in and trigger the emergency shutdown and would print the emergency shutdown code, aka the flag. Luckily, you can't set the PWM value to 255 because whatever you input is multiplied by 28, and there is nothing that you can. No value multiplied by 28 modulo 256 will be 255. So you have to find another way of doing it, which is in the output buffer. If you manage to set a new line character as the very last character of the output ring buffer that's used for this serial output, it will overwrite the index of the input buffer, right? And then you can use that to write outside of the input buffer and overwrite the this target value, and that will eventually trigger the emergency shutdown.
Yeah, you overwrite the target value, so you need to wait for a while for the set the PWM value to this target value.
All right.
Because it will slowly ramp up.
Yes. So, yeah, that's basically a summary of where we at, and we've given 2 hints to the participants. We have told them that it's a buffer overflow and it's in the output buffer, and yeah, they are. I think Niklas has made very good progress on figuring out how this overflow relates to this index and so on. But we are yet to see him put that together into an actual working exploit. So yeah, we just passed the
2-hour mark.
Yeah, exactly.
When should we release more hints?
I don't know.
Yeah, we will see how this progresses. But maybe a good hint would be to say that the debug function is crucial.
Yeah. That would be probably the next step. Yes. So.
Oh, I saw on a PewZ he was trying to figure out what the R1 is. And this is actually one thing that GCC does, because it stores a 0 into R1 and uses that as a constant register.
Yeah, that can be one of these. That's one of these.
I think he is a bit. It can be confusing if you don't know about it.
Exactly. So, yeah, he would probably figure that out fairly soon. Let's see if. So Niklas has a plan. Wait until target is reached. Debug. Pad input buffer so that target reached \n will trigger the bug. Now we have unlimited RAM buff. Oh.
Oh no,
no,
that is not. That
no. So, yeah, so
but he will see.
Yeah. So he thinks that
Yeah.
he has unlimited RAM buffer overflow, and he can write all the way until the stack and do a stack overwrite and return into
The index value is only 256. Yeah, we will see. But it's nice to see that the participants write down their plan.
Yes. So it is. It's actually overcomplicating it. That's unfortunate.
Yeah.
But at least
I think Niklas also soon will run into the last app that I set up. Because the index values into the output buffer are not initialized. So you will need to have a feedback loop. You can't do a blind exploit. You need to read the out and see that the reply you get does not have a new line in it.
all right. So you can't assume that it starts at index 0, or
No.
that's mean.
Yes, but I had to trim down the program size to be under 1K, because the CCC theme this year is resource exhaustion, right?
Yes.
So I thought it would be nice to have a minimalistic challenge. Yeah,
So what you trimmed was the initialization.
or just at exactly 1024 bytes.
Nice. We are pretending that we are demo scene people, and working within the constraints.
Could that be a new theme? 1K Pwnables?
1K Pwnables. Yeah. Should have that as a category on.
Or 1K reverse engineering, because you know that you have a limited size.
So Niklas brought up the live overflow video about format string vulnerability on the Arduino, I think. It's I think it was to just get some boilerplate code for the serial communication in Python. But yeah, so I mean, if you don't already subscribe to Live Overflow, that's your go-to security YouTube channel. I would say, like, if you had to pick one. So
what about your channel then?
Well, I mean, like, if you like pony racing, then of course this is where you go. But if you might want to have like a slightly broader selection of topics, then Live Overflow is the place to go, I guess.
I think weren't you doing a guest play there about AVR reverse engineering a while ago?
Yes. So that was actually pretty funny, because as part of the RHME2 competition that the Riscure hosted, that was in 2016. I did a write-up, video interview thing with Live Overflow, and I talked about like reverse engineering and like some general strategies and stuff like that. And then, like a year or so later, when he was doing the hardware wallet hacking stuff, he basically took the video from our video and just, or maybe he took the audio from that video and put it on top of his video, and it matched perfectly with what he was doing. So yeah, it was a really nice tie-in to that.
But that is also because it was they were both compiled with GCC, and the GCC init function looks the same on those architectures.
Yeah. All right.
But you were having your own name on this copy to BSS segment. I think there are some. If you compile your own binary, you can actually have that the namings in your ELF file.
Mm-hmm. Yeah, let's check back.
And that is something that I would like to see flirt signatures for.
Oh, I see. Yeah, you can probably build that. Let's check in with LarsH. So you can see he's setting the debug initially. Then he's just sending a question, or is it a 2? No, it's a question mark. Is that a help function, or? I thought the help function was help or age or something.
It is both, actually.
Okay, nice.
It could be either H or question mark.
Okay, right. Then it makes sense. So he does that. Print the help menu. So we can see here that Niklas has started writing some code. So first he will receive until he gets the prompt, then will actually sleep, and then he will write debug to turn on the debug mode. And then he will receive until he gets the prompt again, and that works. And then he will receive back his like the output there. So he's just setting up his exploit, and it seems to be working as intended. So that's good. We can check what NSR is doing. Looked like he was like dumping a whole bunch of memory. I'm not entirely sure what he was looking at specifically, but yeah, that's interesting to try to figure out what is he doing. You can that address 124. Lars, do you happen to know?
No, but it's somewhere in the RAM.
Yeah, that looks like ASCII characters.
Yes.
7365. Yes, so that's some string in memory. Could it be the out? No.
Oh, it's set something, I think.
Yeah, because it's a space there. And
yeah, set space something. So it's the command buffer, or one before the command buffer, actually.
Yeah, because there's a null byte. Yeah, that's interesting. So it's checking that.
Yeah, so set 0 should be then 73, 65, 74, 20, and then 30. We have a question in the chat about what the window manager Niklas is using.
Yes. So let's look at Niklas' screen. Is it just i3 or?
I don't know, but we might ask him later.
Yeah. It's hard to tell whenever someone's using i3 because, I mean, the way you can customize it, it can look very different from configuration to configuration.
But he has a nice tiling setup.
That's true. Well, let's check in with PhLaul again. I want to see some of his exploits. And yeah, he's looking at the command handler function then, right here. You can
yes.
Yeah.
Right, he's looking at the input part of this, the function, the checks for the new lines and or carriage return or length 7.
Yep. I see.
So this is the location C7 there was when a command is finished.
Yep. So if we look back at Niklas again, you can see his exploit here. So he will receive the prompt, set the debug, and then he will run set1 twice. So that would print 20, because it starts at 0, right? The PVM, or
no, I think it's I don't really remember what it was, but it ramps up to a value. So when you reset it, it starts off, and then it ramps up to a value.
Oh, no, I mean the target value. So he.
Oh, yeah, that is the target value. So the actual PVM value is 0 and the target value is something else.
Okay. I'm just thinking about if you run set 1 right after startup, that could print like you don't know how many characters it would print because you don't know or is it initialized to something specific? Or
No. Or which, the target value or the index, or what did you say?
no, if you just reset the device and run set 1, will that output a consistent number of characters, or
No, it will not.
no, because it's not initialized to a specific value at startup?
Well, if you do that, no, that will lead to problems. It will be interesting to see how he handles that.
Okay.
Or I think it will be. We might get lucky.
Yeah.
He has a 1 in 32 chance.
Yep. So. Yeah.
But you don't need chance to solve this challenge.
No. It's just some inconsistency there. But you can handle it.
If you look at NSR, he is still stuck in this multiplication thing, I think.
Oh, he's still playing with this idea of...
That's super sad.
Yeah. So...
Maybe you should give a hint that multiplying with an even integer can never be odd.
I could do that, actually.
Because it will be sad, because it's a bit behind. So you shouldn't waste time on that.
Yes, I will do that. So, participants, another important fact. Multiplying an integer with an even number cannot become an odd number. If you take an integer, multiply it by 28, modulo an even number, that cannot become an odd number. So they are informed now.
Yeah.
So yeah.
NSR is just laughing.
Yeah. Yeah. So where
Niklas is having a solution script running now.
Okay. So he wants to debug set 1, and then read. But now he's changing.
Yeah, you can see that get a reply without a new line. He only gets a carriage return. So he's on the right track there. But
yeah, but not always.
No, not always. Sony will be confused and realize that the index pointers are not initialized.
Yeah, do you think he saw the... I think he's trying to find... Yeah, so he's looking at where that is accessed. So he should see that it's not initialized. So where is that total coming from? Is he setting that inside his printing function?
I think it is the total number of bytes that.
Yeah, I would assume that. I would assume it's up in his thing. So yeah, he would need to. So what he's looking for is an output that does not end with \n, and he has received that once by chance, but he probably didn't notice.
Yeah, and it's he seems to confuse that he doesn't get deterministic results, and that is because the index pointer is not updated.
Yeah. But it looks like the output is, I mean, the target value seems to be consistent.
Yeah, the target, yes, but you can see that he did get different total numbers, and that is because he does a reset, and then it will start to do some printout.
Right. So it's actually it's a different It's a differing number of minuses that are printed out.
Yes.
I see. But the thing is that.
But he's on the right track. We're having debug enabled.
Yes. Yeah, I guess the issue here is that even if his total says, because I mean he can only count what he like sends and receives, so even if his total reaches 32, that might not help him because he didn't know what it started. So he needs to reach this this insight. Let's check with phLaul. You can see
doing some length computations.
Yeah, he's been trying to. You can see there he's been trying to send an FF byte, for example.
Yeah, you can also do this set.
So yeah, let's see if we have any other questions in the chat. Someone said he seems to have the awesome. No, NSR seems to have the awesome window manager, and Niklas.
We also have a question about the target reached. Well, what this means is this. There is what this. It's basically setting the brightness level of an LED. And there is one task that actually blinks the LED, and there is another task that is adjusting the LED brightness value, and the target reached means that the adjustment thread has reached the target value. A plus means that the adjustment thread increased the value, and the minus means that the adjustment decreased the value. So the set function in the command interface is setting a target value that the adjustment thread then is adjusting to.
Yeah, exactly. So the set command is not setting the value directly. So the target reach is printed then whenever the actual value and the target value align. Yeah, we can jump over to NSR, who is looking at the debugger, but also, so now he also started writing an exploit script here. So it will be interesting to see what he is setting up, but we'll let him do that and come back to that any moment. So let's see if Niklas is making any progress on his exploit script. So he seems to be connecting to the board for some manual inputs.
No, it was a pseudo terminal.
Oh, right. So he's trying to run this in the emulator then.
Yes.
Okay.
So now it's changing to the PTS.
Right. So hopefully now we will be able to see that the index is not does not have the value that he would expect it to have, and then figure out that it's actually
unless he restarts the simulator every time. We will see if he keeps the simulator going or if he does a reset.
Oh, because the simulator will zero out the memory.
Yes.
Yeah, that's unfortunate.
I think phLaul is looking at the serial output function now.
All right. So hopefully he will be able to find this this overflow here in the buffer. So yeah, it's
he has not named this function yet.
No, that's actually a bit strange.
Yeah, that's peculiar.
So.
And he didn't look further into it.
So now you have Niklas running something in a loop here. I'm not exactly sure what, but let's see. I'm just trying to figure out. Yes, and now he was examining the memory, trying to see what. So he ran his code. Yeah, so now he sees that. So he's comparing, I guess, his 20 from the output of his script against the memory, and he sees that they are not aligned, I guess. So.
Yeah, and then he restarts the simulator. So, and it's unfortunate.
Yeah, it's actually that's.
We have another question in the chat about number of plus and minuses. And when you do a set command, when you do set 0, it sets the target value to 0. But when you do set 1, it will take 1 and multiply with 28. So if you increase the level one step, then you will see 28 pluses. Or if you decrease it, you will see 28 minuses.
Exactly. So.
And this value is chosen 28 because 9 times 28 is 252 post 256.
So there's also a feature there where if you input that, you will get an output that says almost critical, but that won't really help you anyway, except kind of like confirming that you understand what the code is doing. So to check around what the different players are doing again. It's you can see here that LarsH is checking through the data in the firmware, and so moving back and forth in the code. I don't know if he found something when he was looking at the output function that could have helped him, but
yeah, he's still looking at the input. Bad.
Yep. So yeah, I really want to see here who will be like the next one to gain this insight. So you can see that LaRS was naming one of the functions like print buffer or maybe print buffer. And yeah, so NSR is back at looking at the disassembly and decompilation in Ghidra. As you can see, Ghidra handles the code fairly well, produces a pretty nice decompilation. Yeah.
Yeah, that is. Maybe he will spot the missing modulus here.
Exactly. So this is the output.
Yeah.
Output.
He has not named this function anything yet.
Yeah.
So I'm a bit.
Maybe he doesn't roll like that. So. Yeah. So we can see here again that Niklas is running his exploit code against the simulator. So yeah, I'm figuring if we maybe should provide another hint. And
yeah, what should that hint be then?
I'm thinking about what you said about sending a lot of new lines and observing the output.
Yeah, that could be just press enter a few times and see what happens, or
yes.
Or is that mean?
Nah, I would say no. It could just be, I mean, you could be more straightforward and just say that like if you like send a lot of new lines and carefully observe the output.
Yeah, that would be good.
And maybe do it twice to notice that it will not be deterministic.
Yeah. Maybe.
We'll wait. Oh, sorry, I bumped the microphone. We'll give it. I don't know. When did I give them the last hint? Was that like 15 minutes ago?
Something like that.
Yeah, we're actually. I mean, we're at 2.5 hours, so we should give them that.
Yeah, this should be. Yeah, do that.
Well, I will do that. Okay, participants again. If you send a whole bunch of new lines and very carefully observe the output. Very carefully observing the output. And maybe repeat this once or twice as well. Repeat. Okay, so and the source said that he was already doing this, so he felt taunted.
Sorry, I need to fix my microphone setup.
Okay. I think the problem is that PewZ is, or the NSR is doing this in the terminal, which will not render the like any difference between the new line and carriage return. So, or actually, maybe it does. Yeah. So I mean, it would be easier to. Like you could just pipe the output to a file and look at it with a like XXT or something, and you can really see that in some places it's both new line and carriage return, and in some places it's only one of them. So that would be really helpful. So you can see here if it shows on PewZ screen. Yeah, you can see there that he got 2 errors on the same. So maybe that's because it's sent. Yes, so every 32 lines you will get 2 errors without the prompt, because it will send a carriage return without the new line, I guess, and then we'll just write on the same line and we'll overwrite the prompt. So let's see if he will find this out. So it looks like he's scripting this up, and he needs to read that properly into some variable and just like maybe like dump it out like a hex dump or something so that he can really see that you have this difference. So, and someone asked what does the error mean? So yeah, basically when they just send an empty line, that's not one of the valid commands. So the program
just an invalid command.
Yeah, so it will send back error. But the key here is that sometimes they will get back a carriage return without a new line. Specifically, every 32 new lines. Or
yeah, but there
6?
are actually two new lines in the reply, because there is one new line for the error and one for the prompt.
All right. And yeah, so basically, I think the problem here is that they are doing this interactively, or in a way that renders the output.
Yeah, you should always look at the representation of the binary buffer that you get back.
Yeah.
You're doing strange stuff with new lines.
So let's check back with Niklas again. Let's see if he does trigger this. And yeah, it's. I think this thing that it's not initialized is causing a little bit of a headache for them, since you have that inconsistency.
How many of them have a simulator set up? All of them?
I think all of them do, and I do remember seeing it from all of them. I think they were sitting actually. Yes, I talked to them yesterday, and some of them were sitting together and like setting up the simulators and stuff. So yeah, and you can see here that LarsH is also. He's also like he will send what's that, like 30 new lines, and then read the reply. But again, the problem here is that he's just printing it as is. So
yeah, but he will print it. He will not print the representation.
Yeah, I mean,
so
it will actually be a difference in the terminal, but you might just write it off as, oh, it was just a random glitch with the terminal formatting. But it is actually very relevant. So yeah, we'll see when they figure this out. And there's some kind of huge balloon chair rolling by here. Yes, that's interesting. Anyway, there's a lot of crazy stuff going on here at CCC. One of those crazy things being the 11th episode of pony racing. And it's actually like a fun fact is that the idea of doing pony racing was here at a late night discussion at CCC last year. We were a few people talking about doing something like this, and we took some inspiration from the DEF CON live CTF and the Rapid Fire event. Some people hosted a bunch of years ago, but we thought that it was like good ideas that should be brought up again. So yeah, we had this idea for pony racing, and then like 2 months later we did the first episode, and then we've been doing these episodes monthly throughout the year, and seems to be appreciated by the community. So if you're watching this and you know someone interested in binary exploitation, ponyballs, CTFs, you should definitely tell them.
PewZ just found the bug.
It did? Let's
Yeah.
switch to it. So let's see. He is now switching to sending the carriage return. Oh. Is he...
Yeah, so he has written that, and I'm missing when R24 is not equal to
oh, right.
A.
Right. That's good. So if you
Yeah.
can script that up, then he will pretty much be on par with Niklas, I think. And so yeah, what is he doing now? So what did he write? What did PewZ write in his script? Is he just sending a bunch of new lines? And yeah, I'm trying to figure out exactly what PewZ is doing with this. So he's switching to the real board. Let's see if he gets consistent output from that. Maybe he's going a little bit too fast. I don't know if that should affect the result, but it could be an idea to put in a very short sleep somewhere, or not send that much data at a time. So did any of the other participants catch the bug yet?
That's what I can see.
No.
I think phLaul is trying to find out what the other parts of the programs are doing.
Oh, okay, I see.
So like now the port B5,
I see.
which is the LED pin on the Arduino.
Oh. Let's. Sorry, I'm getting distracted by things happening around me. Let's check back with Niklas then. Is he? He went back to looking at the code. Just trying to figure out if he suddenly like started trying out something else, or yeah, just trying to figure out some offsets or something. But I mean, in theory, right? You should be able to just basically, if you in a loop run, just set something, and then send a bunch of FF bytes after that.
You need to have a debug mode enabled as well.
All right, just set debug mode, and then in a loop you run. I mean, it doesn't really matter. Just like run set1, and then send maybe.
Yeah, maybe. That might be a really, really simple script.
Like you could have 4 lines of exploit code.
We can actually try that.
Yes, I will. I don't want to touch anything more right now. My computer is doing a tad too many things at the same time at the moment.
Seems to as a wise choice. I can have a go and see what it's like.
Yes. So we have a question here again in the chat. I'm only familiar with Pwny x86 and 64-bit. What are the main differences to AVR and their protections, canaries, NX, Pi, and so on? So I mean, the big difference here is that you don't have an operating system in the same sense. It's a single process. It's like an embedded system running a single process. So any of course you can build whatever on top of that. You could build a small operating system and so on, but there's no concept of like a file system or virtual memory or anything like that. It's just the memory is the memory, straight up. So that's a difference. When it comes to protections, that's also, of course, dependent on what you're building and like what you can implement. How I mean, it doesn't have virtual memory, so I guess NX is pretty much out of the question, unless you have that implemented.
Some microcontrollers do have memory protection, but not the Atmega 328.
Yeah. Stack canaries, of course, you can implement. Since that's like a purely software thing. Though you would need some mechanism to kind of like randomize the canary or something in the beginning, but that can be achieved. So it's also, you don't really have. I mean, when you're opponing on a regular computer, your program is some kind of like binary format that has been loaded, that has a certain structure, like an ELF binary on Linux or a PE binary on Windows, which will contain all of these like metadata structures, like the headers, and if you have dynamic linking, you will have like a linking table of some sort and all of that. And I mean, again, you don't have an operating system, so you don't have those things. It's just the code straight up as a flat file, and then maybe like some constants or global data somewhere else. So it will just start running at address 0, for example, and the code that's there, that's the code that will run. Yeah, so there's some differences, and if you want to try out this, I would highly recommend to check out the RHME challenges. They were 3 CTFs organized by the Rescuer. They are a security company working a lot with like hardware and embedded security. So was it like 2015, 16, and 17? They did these challenges centered around AVR, exploitation, and other hardware challenges. and they put most of the challenges online on GitHub, and you can play them using a regular Arduino Nano board, at least RHME 1 and 2. So you flash that onto one of the boards. So RHME 1 is just a single multi-stage challenge, and RHME 2 is like a collection of like 20-something challenges. You can flash them one at a time on the board and try that out. Some of them are about exploitation, some of them are about cryptography, side channel attacks, and so on. So it's like if you would play through all of those challenges, like if you would complete all of the challenges of RHME 2, I would say that you probably have a really pretty solid foundation on like the main topics, or at least a whole bunch of topics on like embedded attacks. So want to check in with NSR again. I saw that he was writing some exploit code. So trying to see what he's doing. Running this in a debugger. Yeah. So Lars, did you try the?
Yeah, it wasn't that simple. So
Okay.
I tried to run it the way you said to, but no, it seems to be harder than that.
Okay. So why wouldn't that work though?
It should work actually.
Yeah.
From what I can tell. Might be me just doing a stupid mistake.
Yeah.
Like always when doing CTFs.
Yeah. When you're in the middle of it, and you get that small little detail wrong, and then you go down a deep rabbit hole. We've all been there. So yeah.
Yeah. I'm trying to feel if they are close, or like where we want to go from here. We are coming up on the 3-hour mark, and yeah.
I mean,
this should be fun. This should not be a pain. So
yeah, we should. I mean, I don't know. We don't want to drag this out for too long, and it's so unfortunate that. I mean, Niklas is really close. There, you see it. Target reached. Missing a new line at the end.
Yes, that is exactly where you want to go. Yeah, he's very, very close. If he just modifies his plan to overwrite the stack, but I think he will understand that once he tries it, that he can only write 256 bytes, and then it will wrap around to the beginning again.
Yeah. By the way, won't the when he starts doing this overwrite? Okay, right now he's not writing FF. He's writing some other value like A. But either way, the program, the device should start outputting, because he will overwrite the target value, so it should start outputting like minuses or pluses.
Yes, so he will probably realize that the target adjustment value has changed.
Yeah, because it will suddenly spit out a bunch of those, and then if we investigate that further, he will realize that it's the target value, and then maybe then he can just overwrite that with a FF. Yeah. Let's hope.
But he's running it in the debugger, so.
All right.
So he's looking at what values. Oh.
Yeah. So let's check in with PewZ again, who also had found, or we think had found this bug. So yeah, he's looking at the ASCII values of minus and plus as well. Maybe trying to see if they are in the output buffer. So yeah, not exactly sure what's going on there at the moment. Oh yes, so here Niklas is setting up some...
He's doing a ROP effort. But he will not reach there.
Oh.
But it's I actually had this idea to put the global variables closer to the stack.
Yeah.
But no, not in this case.
Yeah. That's So which address there is the target value? Is it the input digit? That must be it, right? So now he's going to write a whole lot of A's.
Yes, but he will realize that it will only write. Yeah, the program will die after it reaches bit modulo 256.
Why will...
Because the index pointer is an 8-bit integer.
Yes, but what happens when it
so you can
wraps
see
around?
that, yeah, now he will get first this one and then he get errors.
Yeah. But this should also print a whole bunch of... yeah, you can see a plus there.
No, oh damn.
What?
He wrote oh damn in his script.
Oh. But you can see there, for example, in the middle there's a plus.
Yes. So definitely, if he only wrote like 10 8s, then that would have solved the. He's so close.
Yeah.
If he just write F instead of FF instead of AA, he wins.
Yeah.
So
it's so close. It's
yes.
So tense.
But he needs to understand how the different tasks collaborate.
Yeah.
To,
yeah, I think he starts looking at the timer thing now.
should become.
Look! He highlighted the input digit. He highlighted the input digit. Oh.
Yes.
Is.
Now I think he's.
Oh damn! It wraps around. Easy.
Easy then. Let's see if he understands that he could just write. Yeah, this.
Wait. So actually, he's thinking now? I think that he's thinking that he could just wrap around all the way. And this is.
We will see what he comes up to. But it's really, really interesting to see how we.
Yeah, that's really close. I believe in him.
Mm.
But what would happen if when you continue reading? No, right, because then it wraps around and then it eventually reaches. Then we're back in the ring again because.
Yes.
When we
just start to.
When we reach 30, or was it? What's the 7? Sorry, when we reach 7 again, it will stop there, and we're back trapped inside the ring.
Yes. So it's this value that he has named input digit, which is actually the adjust target variable.
Yeah. So.
So just when he realizes that if that value is set to 0xFF, then then he has won.
Yep. So it's so close, so close. Let's see if the others are progressing. We can see that NSR still messing around in the debugger, checking the memory. Do you see what he is looking at? It's kind of difficult to follow, unfortunately. Now it prints a whole bunch of. So will if you run the debug command really quickly, because the current value and the target value, they might start at completely different levels. So if
yes, they actually do.
Okay.
The value starts at 0, but the target value, because when you start this chip, the LED brightness ramps up.
Right. So if you run the debug command fast enough, you will immediately see a bunch of pluses outputted.
Yes.
Even though you didn't do anything. So that's also
yes.
Interesting information.
Mm.
So if we check in with Niklas again. I mean, you can see there in his output there are a bunch of pluses that shouldn't be there.
Yes, and he doesn't know. It's so close.
Yeah. Oh, it's so frustrating.
Yeah.
To see it, to feel the pain. It's. So looking here at phLaul, he's also playing around here with the sending different values, and then he's trying to seems that he wants to try to mix the set and just some A's, which is an interesting idea. I mean, it's definitely something I would try. I mean, I guess it won't really help in this specific case, but I mean, the idea of causing some kind of race is interesting. So we can look here at PewZ screen and see.
Because PewZ has also found this, right?
I mean, he has. I mean, he has seen it, but the question is, did he understand it? Did he notice it?
Yeah.
That's a big question. So. Yeah, it's basically. Yeah, so if Niklas would just figure out what that byte after the timer means, he should have it.
Yeah. He just needs to change this AA to FF and he will win.
Yeah. It's, that's really interesting. So now he's back looking at the code, seeing if he missed anything. I'm not sure exactly which part of the code it is. It is the adjustment part.
Yeah, he has just named it checker.
Yeah, no, that was, he named it checker like a long time ago. But he is back in this function as checking. He needs to look at that the thing that he calls input digit and realize that it must be that it's relevant.
Can this go negative? Yeah.
Yes.
Yeah, it could take any value actually. Well, it cannot take the value new line minus minus 48.
Yeah.
X30.
We got a question here from Jordan that the goal isn't code execution in this case, right? And if so, do the competitors know that? So no, code execution is not the goal. It's just dumping the flag from the board. And I have told the competitors this. So They should know it.
Code execution is a bit hard on AVR because there is a different program memory and data memory.
Yeah, I've done so in one of these RHME challenges I mentioned earlier. There was a challenge where it was probably, I think it's one of the best CTF challenges I ever played. It was like a series of 4 challenges or something involving a virtual machine on top of the AVR, and then you would like gradually, first you would just like reverse a program inside the VM, and then you would find a bug in the VM to leak some memory outside of VM, and then finally you would use that to get like ROP inside, or like to break out of the VM and ROP on the AVR. That was a really cool challenge. So
ROP is obviously possible.
Yeah. But you can't write executable. You can't create executable memory.
Unless you do some ROP to the bootloader and write to flash and stuff, but that is complicated.
Yeah.
I think NSR is looking at the function with the the put character to the buffer.
Yeah.
Wondering if he realizes that there is an and there. It's not sure.
Definitely not sure.
phLaul is also looking at that function, so
let's check here.
But he has named it right character now, so
okay, that's interesting. And it's print, but it's actually not print.
Oh, it's put string or something like that.
Yeah.
But I wonder if he has found out what it's doing.
So he wrote a comment that the argument is in R24. So yeah, it's comment from Jordan: Harvard architecture for the win. Fully agree. And yeah, if we check back with Niklas again. So, as we said before, no, he changed this now a little bit. But yeah, basically, as the script was a moment ago, if he would switch that A for an FF,
/XFF,
yeah,
then it's a win.
Yes.
But he also needs to make it a bit more, because this is only open loop now. He doesn't read anything from the device.
Yeah.
So to make a stable exploit, you need to make sure that you read until you get this target reached without a new line.
Yeah.
And he's not doing that at the moment.
Yeah. So wondering if we should provide some more hint for the participants.
Like FF is better than AA.
No, but you could say that actually. I was thinking about this.
Do they want source?
Yeah, I wonder if that helps them at the moment, but
I'm not sure.
Because it feels
that
like
source is hideous.
Yeah, that was what I'm saying. Like maybe that it would just slow them down actually. at this point.
Yeah. Because when I wrote the program, I wrote it so I could test it on x86. So every assignment is cast uint 8t and all variables. So
yeah, that's horrible. So we can see here again, Niklas is just looking at like the memory layout, and he's so focused on this like should become FF that he is. I think he's not really paying attention to the
input byte.
Yeah, what he called input digit. So I'm just thinking that you could do saying something along the lines of, you know, that there are like two ways to set this target value, or like maybe let something else set it for you, or I don't know. Yeah, so let's check here again with PewZ. You can read his exploit code. Enable debug, then send a bunch of new lines. So yes, he sends the debug thing, and then sends like 256 new lines. But then he's just switching to interactive. So what he should be doing is like read the response of that and check and see that there are inconsistencies where sometimes the new line is missing. Yeah. So let's hope he will do that. So now I'm using some wireless headphones and they are running low on battery, so that's gonna be an issue.
Unfortunate.
I hoped we would do this, in a shorter amount of time. But yeah, we should probably release some kind of hint here where.
Yeah, what should we give them?
Yeah, I'm just like thinking about like, should we give give a hint that would help Niklas to push him like over the edge, or across the finish line, or do you want to give a hint so that the other players catch up? It's a little bit of a tricky situation when you haven't like decided this ahead of time.
Yeah, we could ask the chat.
But yeah, I mean, we're also running over 3 hours now, so
yeah.
Let's so
but we can think of what could the different hints be.
Yeah, but we could do something just that there are two ways to
control the target value.
The target value, yes. But maybe that's actually a bit confusing. It should be. So.
Or if you say that the target value can either be controlled. Maybe we could say that there is an off by one bug. That would help the others. And we could say that we can give a hint that helps both.
Yeah. So.
And.
Just thinking about this. Yeah, so exactly. There's an off by one in the
In the output.
Yeah, in the output buffer, there's an off by 1, and it's.
Oh, PewZ is doing a Zeta 3 event.
Oh, no, that. So is he still trying to figure out?
I'm wondering
if
what he's.
can do this multiplication.
Wondering what he's looking at.
Yeah. What's the F? Is it FB or?
Yeah, that is 250. So it's the warning threshold.
Almost critical.
Almost critical.
Yeah. Right. So yes. So we have an off by 1 in the output buffer, and we have.
And FF is better than AA. Is that?
Maybe that's a bit too much, but we can just say that you don't need to. You don't need to. What do you call this value? The target value. No, sorry, not the target value. The PVM level. But they won't. I don't think they will understand what we're referring to. Like, how do we name this variable?
We could give them the variable name structure.
Yes.
Could that be helpful?
Well, or we could just, if we can just get the address of that thing, if we can look at someone's screen.
We could do that, yeah.
Yes. So if someone could just switch to the memory view so that we can see the address of the target.
We should have done this earlier.
Yes.
To have a memory map. But we note that for upcoming challenges.
Yeah. We should probably have like a few hints in store before starting. But you know, it's one of those things that's hindsight is 2020 and so on.
We were focusing on getting the stream.
Yeah, exactly. So yeah, so yeah, we'll provide them with these hints then. So they off by 1 in the output buffer, and that they can get the code to, like, they will need to get the code to set this target value for them. No, not the target value. They
will
the counter.
The adjustment target. We could actually say that because we can refer to the second last function call in the main loop is the adjustment task.
Yeah.
You can say that the second last function in the main loop is your friend in the end.
Yeah. So it would. Okay. Yeah, I will tell them this. Okay, so they have been given these two hints.
So Niklas is going straight to the looking for references to this function,
Yeah.
which is exactly what he should do.
Yes. So he's checking. He's found this function where it's incremented or decremented.
Found the adjustment function, yes. And now he found input digit. And now he looks like yes.
Yeah. So let's see if he can turn this into a.
Yeah, he will probably convert this pretty quickly now.
So. Yeah, is that? Yeah,
That's probably the offer. Yes,
that's correct. But I don't know why he wouldn't just fill it with FF. But yeah, sure.
Yeah, I don't know. Whatever floats it.
So I mean, I kind of want to look at the other players, but I also kind of want to see this work. So.
I can have a look at the others and see if something interesting has happened.
Yeah. So is this when it goes down? Okay, so he's trying to run this on the emulator now. So is anything happening at all? Well, he's sleeping for 30 seconds. Okay, so we will have to wait for a few moments before we see anything.
Wonder why.
Maybe he wants to make sure that all the stuff has finished running, and then he instead of like reading, maybe he didn't have a good mechanism for reading like continuously and like hoarding, so he just wait 30 seconds and read everything. But
yeah, they have been sitting for 3 hours straight now, so
yeah, 3.5
almost
even
3.5
plus the half-hour delay.
Yeah.
So it's also maybe this emulator is not super fast. Oh no, so he's adjusting the number of A's, and then wait, shouldn't he do the? So now he's doing target reached. Yeah, it's it's not quite working out for some reason. So let's see what he's doing. He's writing set 1, and then he's writing a bunch of A's. But shouldn't it be the other way around? I'm a bit confused here, actually.
Yeah, I think the first right there is just to get the serial buffer in the correct position.
Sorry, to get the serial
buffer in the correct position.
Okay.
Yeah, you can see that he get their target reached with a new line there in the bottom. So.
Yeah.
Oh, did he have a solve locally?
Oh. Yeah, he copied it to a solve local, so yeah.
It's interesting.
Well, I mean, if he has something that works locally, then he could just run it a bunch of times against the real board, and it would work. So it's Final stretch. Is he gonna make it?
Mm.
I think maybe I would like him to decrease that sleep a little bit so that we can get some more action going on.
I think PewZ has found the overflow now also.
Let's check with PewZ. Yeah, it's. Oh, you can see that he is. He has somehow.
Yes, he has a local solution.
Oh! He has a local. Niklas has a local.
Yes.
So let's switch over to Niklas. You can see there in the bottom right, he has. You see all those Fs in the bottom right corner.
Yeah.
So now he just needs to run.
Yeah, he needs to make it deterministic. Run it a few times to see if it.
Let's see. If we just
Because
we just need to
right now it has a 1 in 32 chance of winning.
Exactly. So he thinks that adjusting the A's actually matters, but actually it's just about running it a few times.
Yes. Or he could reset it from the beginning. That would also work, probably.
Yeah. I mean, like running it a few times or resetting doesn't. As long as he didn't accidentally create an output of exactly 32 bytes.
But he's so close now.
Yeah, it's so close. We get it any moment.
He has it in the simulator,
Yes.
but he
Yes.
just needs to get it working
Yeah.
on the real metal now as well.
Yeah. So this is when it happens. You can do it. Just run this exploit, and get the flag. But now he's connecting to the simulator again.
Yeah.
I don't know. Why isn't he trying this on the real?
I think he's doubting that it's working.
Yeah.
But yeah, he's so close. He has it now. He has it locally. He just needs to get it on the metal.
Can we get a little bit of a hype from the chat? Just gear up for the flag. So, how are the other players doing? We can check with PewZ. Yeah, no, it doesn't. I mean, you can see he has written some notes there. Off by 1 with negative size, overwrite buffer position. No, that's unfortunately not the right track. We can see here now Niklas running the exploit again a few times. So
Well, he has this total value that is different all the time.
yes.
To be honest, I was also struggling with this when I had to test the challenge myself. This wasn't initialized. So what you should do is just write set 1 on and on and on until you get a reply with target reached without this new line.
Yeah. So now he's running it against the real board.
Mm-hmm. That's great.
So now he's like trying it over and over again, and just making small adjustments to the script. He's like actually now taking the... Oh right, so now he's taking this offset as an argument, or like the number of A's to write. So maybe he's just gonna run it in a loop or something. Yeah, exactly.
Yeah.
So actually this is good, but not due to, like, not because of that. It's good because he's running it over and over again.
And he will get so confused when it's not...
Wait, is he actually printing the output this time?
No, he had 2 exits, so
Oh.
even when he gets a success, he will not... it's unfortunate. But fortune works in both.
Yeah. It's really unfortunate. Basically, if he would just take the solution...
We have a lot of hype in the chat now.
Good. Great hype. We want the flag. Yeah.
We also had an interesting idea in the chat to have a advancement progress graph.
Yeah.
We could have defined checks like reversing, getting it to work, finding the bug.
Yeah, exactly. I think my headphones died now, so I cannot hear what you're saying, Lars. So please keep talking while I get a solution for that. And yeah, I'll be right back.
Oh well. And I also cannot control what we see because that is on Kalle's computer. But right now we have Niklas here trying to fix his script.
Okay, great.
So he's still going for the approach where he has set up the argument. The input and try to get the right offset for the exploit.
Det är väl inte ett sånt jack på de här? Alltså med mikrofon i Macbooken. Nej förlåt, mikrofonen har jag här, det är bara hörlurarna. Det är lugnt, jag är dum i huvudet.
Different offset every time because the reset does not reset these indexes in the ring buffer.
Hello again.
So, hello, welcome back. I just spoken a bit about what Niklas is up to and why this is a problem for him.
Yeah.
How are your new headphones?
No, you can press the reset button on the board if you want to. The white button on the middle.
We can also see Niklas holding up the shear.
That will reset it. No, just click it. Okay, sorry. It was Niklas had a question about if he had to restart or like unplug and replug the board, but yeah, he can just press the reset button on the board. That works fine. So
I'm not sure if it will reset the RAM.
Right.
But we will see.
Yeah, that's a good point. But I mean, it seems to be running after he does that, so...
Yeah, but you...
I'm very unsure about this.
So I think PewZ is writing at the moment... No. Jumped away from that.
Yeah.
But we should have a quick look at the others as well, not only focus on the...
No, exactly. So
on the
we
lead.
can see
there.
what NSR is doing. Yeah, still a lot of stuff going on there in the debugger, trying different inputs. I mean, I'm not at all sure where he's going with that. Unfortunately, can't really give a good commentary. So yeah, there was this thing in the comments about having like checkpoints and defined stages and stuff, and it is a nice idea. It has been brought up before. The challenge is what Jordan says, that it's not actually always easy to know what the contestants are thinking. But I mean, of course, you could do like a best effort guess and have some like subtasks and try to check them off. We have been, toying with the idea, but we haven't managed to implement it. But it's, definitely something to consider. And yeah, we'll see if we can effectively do that in a future episode. And now the Eye of Sauron is staring at me again. So yeah, I went half blind, but I'm back. It's yeah, you can really sense the frustration here from all of the participants. It's over 3.5 hours, and it's things are acting strange, and you start doubting even your most basic assumptions about the code and your exploits.
Hardware always makes you do that.
Yeah. And it comes to like, wait, is this even ASCII? Or it's just, you start thinking really strange things after a while. So yeah, I don't know what NSR exactly is focusing on now, right? Either checking with LarsH again. You can see he has commented out a lot of stuff in his exploit. Tried a bunch of different ideas. Probably didn't find anything that that he liked. So now let's switch back to Niklas. He's running it against the real target. It did not work again. Could be. Yes. I would just take the solution that you have for the local and just run it a bunch of times. Because I know exactly where it's failing, and yeah. So you missed one thing, but you still have a 1 in 32 chance of it working. Yeah, so I talked a little bit to Niklas, and I actually told him that his local exploit should have a 1 in 32 chance of succeeding. So
yeah,
we'll see
fair.
if he if he will go with that. I want to see here. Is he gonna run it against it or? So now he's running against the simulator again.
Mhm. To see that it works, or what? Can you
Yeah,
see?
I don't know exactly. I don't know exactly what he's trying, but want to
Did the other participants hear you say that to Niklas, by the way?
yes, yes.
The frustration.
So I don't know why his script is not finishing. That's a bit unclear. But oh, there. So yeah, so he gets the dump. It works on the emulator. So he should just run that on the real device.
Yes. A few times.
A few times.
Which he...
Yeah, is he still sleeping like 30 seconds or something? No, it's... Yeah, so now he's running this in a loop to see if if it will work.
The thing is, when it works, it will hang. So then it will probably get a lot of error messages.
All right, and he's breaking on. But no, it should work the same way in this as it did in the simulator, right?
Yes.
Oh no, because after it prints the flag, it will just go into a infinite loop and not do anything else.
Mm-hmm.
So that should be the last output he gets.
Yeah.
So actually, wasn't that was just old scrollback. It looked like.
Yeah, there will be no. I'm not really sure what you shows as a flag. But it will not be FF if the flag is set.
Oh right, it will be null terminated.
Yes.
Right. I just kept the flag that you had in the.
The demo flag.
Yes. I did check that it was appropriate first. So now he is actually randomizing a bit on the input of the...
That will not work.
No. But it will be as like... I mean, it doesn't hurt him, but it doesn't help him either.
No.
So the only thing that's important here is just to run it in a loop, because since he's not doing this, so I mean the proper way to do this is to
read the output and see when you get target reach without a new line in it.
Exactly, so that you know what the output buffer index currently is at. But since he's not doing that, he still has a 1 in 32 chance of aligning it correctly, so he could still win. So I mean, the flag could basically pop any moment here.
So, I will have a quick look up what the others are doing.
Yeah.
I think both PewZ and phLaul are looking at this put character, but I think phLaul has misunderstood the direction of the register, so he has probably read one character where it is this NQ character.
Yeah.
No, it's not the send UART character. It's probably. That's unfortunate.
Yeah. So is Niklas still even running the exploit, I wonder? Let's first check in here with phLaul. Yeah, he's looking at this, the UART communication. Is that the send function, right? It writes to the serial. No, wait. Yeah. I'm not sure. It's one of the serial communication. Or was it the part that reads from the... No, it should have been the serial send part. Anyway, so it looks here like Niklas might have seen what's the issue, and because he was communicating manually here in the terminal with the thing, and you can see there, like the second to last thing, it's there's a new line missing there. And oh, look, he is... looks like he's setting up a loop here to do this.
That's also made to do it.
Yeah. So what you would do is just send a new line until you get this difference. And actually, you don't even need to be very smart about it either, because as long as you do this consistently, you don't need to calculate the rest perfectly. The rest can just be found manually. So, like, if you first start with this loop to send a new line until you get this discrepancy, then you abort that loop, and then you have some variable that says how many characters you will write before this final set thing. And then you just adjust that variable, because as soon as you get out from this first loop, you are in a consistent state.
Yes.
It's a reproducible state. And from there you can fiddle with, like, how many characters more do I actually need to get the flag. So you don't need to, like, count exactly how many characters. You can just try it out.
It's very close on that. But will he be overtaken? We will see.
Yeah, exactly. We can see... check in with LarsH, who is looking at the... Oh, here's the input stuff, like the process to command. You have the compare with 7 there on screen. So, yeah. Here you can see Niklas sees this discrepancy here. You can see that there are 2 carriage returns. Oh, we have a winner! Congratulations, Niklas!
Yay!
Yeah, so we're slightly behind on the stream, but Niklas managed to get the flag on his screen, and we should have it on screen now, right? Yes, awesome. Yeah, wow, what a show. What a competition. Just under 4 hours. So we will do it like this. We don't have a good. Usually we do a bit of like a post-match, interview and discussion with the players, but we don't really have a good setup for that right now. So what we'll do is that for people who are here at CCC, feel free to come to the Exil assembly, XIL. It's in the, I think, I'm not mistaken, close to the big Eye of Sauron. Yes. So with that, I will just finish up with some things. We will be releasing a community challenge. But it might not be tomorrow as usual. So for those who haven't watched before, we usually release another challenge the day after we send an episode. And the community challenge is a pwnable challenge that all of you can try at home. And if you solve the community challenge, you have a chance of being invited to the next episode of Pwny Racing. So if you think that this was really cool and interesting and you would like to participate, this is a great way of doing so. Now, I should say that this challenge today was a little bit more difficult than usual. We usually don't go on for like 4 hours. We usually aim for like a 1.5 to 2 hour episode. But yeah, today was a little bit special. I mean, it is here live
disconnected from your
CCC
channel.
after all. Did I just lose Lars? Probably did. Anyway, I would like to say a big thank you to Lars, who has helped out commentating and who wrote this challenge, and to all the participants who played today. They're really awesome Pwners, and a big congratulations to Niklas, who was the winner of today's challenge. So yeah, feel free to come to the Exil assembly and hang out with us and talk about Pwny Racing. With that, we'll be closing down this stream. So thanks for watching, and if you enjoy this, subscribe so that you don't miss the next episode. We usually do this once a month. We have Lars actually back, so I can actually hello, Lars.
Hello.
Hey, I just wanted to say I was just doing some closing statements, and I just wanted to thank you for writing the challenge and helping me out with the commentator stuff.
Thank you. I hope the participants enjoyed it.
Yeah, I will talk to them, and I will carry their feedback back home to you. So yeah. Anyway, thanks.
Also carry home stickers if you have the.
All right, if you want Pwny Racing stickers, by the way, you can come here and get them from me. So yeah, with that, thank you for watching, and I hope you will listen to the next, watch the next episode in a month or so. Goodbye.